Good morning, everyone. I hope you all are doing fine. And guess what? Today, we are going to dive into the first concept of Unit 5 Mathematical Reasoning and Aptitude. We're going to discuss number series today. But let me introduce you that what is this number series and why this is important. Imagine you're lining up your favorite comic books, action figures, or even your playlist tracks in a certain order where each item follows a secret rule. Remember, number series are kind of like that, but with numbers and sometimes letters that we'll discuss in our next session. So it's like treasure hunt where each clue or number leads to the next following a special pattern or rule. So these rules aren't random. They're based on cool math tricks like adding, subtracting, multiplying, or even more creative stuff that we'll discuss. So when we talk about number series in the world of puzzles and brain teaser, we're looking at a lineup of numbers that are playing follow up the leader based on secret math rules. Sometimes the game involves number chilling in a sequence and one of them decides to play hide and seek, and that's where we have to find that missing number. And other times one of the numbers is the rebel not following the rule, and you have got to figure out which one is breaking the pattern. And the cracking the code means turning on your detective mode to spot the pattern. Let's say you see a sequence like 2, 4, 6, and 8, and there is a missing spot. And if it feels like counting by twos, you're right. So the missing buddy is 10. So, but not all the series are this kind of straightforward. Some might require you to think outside the box, like altering between adding and subtracting. Right, so imagine you and your friends are on a kind of hunt. You find a clue that says follow the number, and you're given a series like 5, 10, 20, 40. So the treasure is hidden at the location corresponding to the next number. So you realize each number is doubling. So the next spot is 80. So there is your kind of treasure, right? So playing with number series isn't just for kind of starter. It sharpens your brain to recognize pattern, predict outcomes, and solve problems. Skills that are super handy not just in math but also in your real life, whether it's figuring out how much money you'll have at the end of the month, planning your study schedule, or deciding how many episodes of your favorite show you can binge watch before your exam, right? So, there are so many types of number series. We have addition, subtraction, multiplication, division, square, cube number, and there is this Fibonacci and altering number series. Then we have mixed operator. There they ask question based on that in your exam. So we have to follow the pattern and we'll know what we are gonna talk about. Anyway, so first let me tell you about the addition number series. So think of this like a stacking up Legos, right? You must have played that game, right? And you start with a base number and keep adding a certain number to it to build your tower. For example, if you start with 2 and keep adding 3, you'll get 3, 5, 8, 11, and so on. We'll understand this by the example, and we'll discuss all types of example after discussing what kind of question you might face in your exam. So the first was addition number series. Next we have subtraction number series. So this is the reverse of adding, right? Like eating a chocolate bar piece by piece. You start with a big number and eat away a bit of it step by step. If you start with 10 and take away 2 each time, you get 10, 8, 6, and 4. Then we have multiplication numbers. So imagine this as supercharging your numbers. You start with a number and keep multiplying it by a certain number to get the next one. If you start with 2 and multiply by 3 each time, it goes like 6, 2, 6, 18, 54, and it gets big fast. Then we have division number series. So think of this as splitting a cake evenly again and again. You start with a big cake, which is your number, and keep dividing it, starting with example 100 and dividing by 2 each time. You get 100, then 50, then again divide by 2, 25, and this keeps going. Then we have a square number series, and this series is all about numbers that are the squares of whole number. So imagine each number is a square tile, and the series is like 1 into 1 is 1, 4 is what? 2 into 2, then 9 is what? 3 into 3. So it goes like this. Then we have cube number. So it is by the word you can understand. It's all about that cube. Like here, you see 8, which means 2 into 2 into 2. Then there we have 27, which exactly follow the same rule like 3 into 3 into 3. So these kind of patterns will come in the exam. But remember, they usually ask the mixed number. So they add all this in one series and you have to find the pattern. Then we have Fibonacci number. So this one is like a rabbit family tree. Each new number is the sum of the last two. So if you start with 0 and 1, the next number are what? 1, 0 plus 1. So what it is? 2. Then what? We have 3, like 1 plus 2. Then 5 is 2 plus 5. So it goes like this. Then we have altering number series. So picture this as mixing up dance moves. You have two different steps and you alternate between them. If one pattern goes up by 2s and then another goes by 3s, so you'll dance between these two patterns. Then we have mixed operator number. So in exam, this is where you get question. You mix different moves, some addition here and a bit of multiplication there, or sometime division, sometime it could be subtraction. So all these things are there. So for example, you might add 2, then multiply by 3 and repeat. So it happens like this in your exam. Next we have arranging the number series. So imagine a puzzle where you have to rearrange the pieces to see the full picture. So usually you don't get question based on that, but for our reference we have to know about it. So here numbers might be out of order and you have got to shuffle them back to their rightful places according to the hidden rule. So let me tell you about some tips. So what you have to do when you see these kind of questions, first you have to detect the pattern, if it is addition or subtraction, or it is about multiplication or division. Then you have to identify the process, what is happening there. So process identification is a kind of key to find the correct answer. Then we have tip, which is like rearranging series using various mathematical process. And what happened, you have to find the correct answer through series rearrangement exploration. Let me tell you about more these tips. So imagine you're a detective, but instead of solving crimes, you're cracking the codes of number sequence. You have got a line of numbers, and your job is to figure out what secret operation is happening between them. And are they getting added together by a certain number each time, or are they doubling in a game of numerical leaf flow, or maybe they are taking turns subtracting and dividing, like they're playing some kind of mathematical tag. So you have to recognize this particular, you know the pattern. Let me give you a real life example. Let's say you're tracking how many candies you eat each day for a week, because why not? It's candy, right? Or on Monday you start with 2 candies, on Tuesday you have 4, by Wednesday you're up to 8. So see the pattern, you're doubling your candy intake each day. That's additions. And then let me tell you about the tip 2. So now imagine you have got a jumbled mess of numbers, and it looks like someone took a bunch of digits, threw them in the air and wrote them down in order they landed. So your mission, should you choose to accept it, or is to unscramble this numerical mess into a pattern that makes really sense. Let me give you the real example. Picture this, you have got a playlist with songs ordered by how much you like them. but your little sibling rearrange them randomly. Now you have got to sort them out, right? It's difficult, but with numbers it's similar. You might see something like 9, 1, 8, 2, 7, 3 and think what's the deal. But if you look closer, you'll see there's a high-low pattern, like a game of numerical ping pong. You're just bouncing back and forth between the highest and lowest numbers and getting closer to the middle. And the key to nailing these number series puzzle is to put on your detective hat and look for clues, which is your pattern, whether it's spotting a pattern of addition, subtraction, multiplication, division, or even some fancy altering action. So there is always a method to the madness. And when it comes to jumbled numbers, think of it as a puzzle where you're piecing back together the original masterpiece. Now let me tell you all the examples of different types of number series. We'll start with the first one. As you can see over your screen, you have the question like find the next number in the series, which is like 2, 6, 12, 20. What will be the next? So let me tell you the pattern. So if you know the answer, you can just write in the comment box quickly and pause, and then I'll just share you all the solution, how it is happening, what is the pattern, and what is the correct answer. So let's begin the solution. Let's start with 2. Our next number is 6, and if we add 4 is to 6, right? Then the next is coming 12. And how? When we add 6 plus 6, then next is 20, and when we add 8 it becomes 20. So through that we understand it's actually adding even number, and finally we get the answer, which is what? 30. So that is our answer. So in that way you can just find the pattern. Okay, let's take another example of odd number. You see the question 3, 9, 17, 27. So when we simplify, the next number is 9, right? So when we add 6 plus 3, we get 9. And then it is 12 plus 5 equals to 7. So we see it's all about odd number. And the answer will be same if it follow the same pattern. 27 plus 9 equals to 36. So that is our answer. Let's take an example of subtraction now. So the question says find the next number in the series, and the series is like 64, 58, 52 and 46. So what is the pattern happening here? Now imagine on the first level, you score a whopping 64 coins because you're just that awesome. But as you move up, the game gets trickier and you lose 6 coins each time you level up because of those trap. And here we see the pattern. So let's break it down like we're going through the levels. So first level 1 says 64. So yes, you have 64 coins. Now the next level it goes, you lost 6 coins, leaving you with 58. Then the level 3, you see, now you lost again 6 more coins and you are left with 52 coins. Then level 4 says the same, you are at 46. So now you're probably wondering what's waiting for me on the next level. Well, if these traps or this pattern keep taking away 6 coins each level, you can bet you're going to have 40 coins by the time you hit the next one. So the answer is 40. Now let's take an example of multiplication. And you see the question here that it says in the series we have to find the next number 3, 9, 27, 81, and what will be the next. So here's how we figure it out. Every time you snap, you're just tripling the amount of candy you have. It's like every piece of candy suddenly has 2 more buddies pop up to a next. So let's start with 3 candies, and now you have got 9 because 3 times 3 equals to what? 9. So you have 9 candies. Now next it says 27. So what? 9 times 3 equals to 27. So it follows the same pattern. And next is our 81, which is like what? 27 times 3 equals to what? 81. And the next one, we have 81 candies, right? And next, what will be easy, right? You're gonna what? You're gonna multiply by 3. And when we do that real quick, we'll get the answer 243. If we were picking what comes next in our super cool candy multiplying sequence from the option given, we'd go for what? C, which is 243. So that's our answer. Let's take another example of division. So the question says find the next number in the series which starts with 1024, then 512, 256, 128, and we have to find the next. So options are already given. So this series actually follows a pattern of dividing by the previous number by 2. So let's start with 1024. So when we divide by 2, we get what? 512. And then this next number 512, we divide again by 2, and what we get? 256. And we follow the same pattern and again divide this 256 by 2, we get what? 128. So it's easy to understand what will be the next number. So when we divide 128 by 2, what we get? The answer 64. So the next number in the series is 64, making the answer what? 64. So this sequence illustrates a straightforward division pattern which each number is half of the previous number. Okay, let's take another example of square number. So in the question says identify the missing number in the following square number series 149, and then there is a question mark that we have to find, and then we have 25. So we know it's kind of very easy to spot, but let's find the answer. So the series represent what? Square numbers where each term is the square of consecutive natural number. So first we have 1, right, which is, if we just put square, we'll get the answer the same, right? 1. The second term 4, which is just what? Square of 2. Then the next is 9, which is just simply what? Square of 3. So exactly if we follow the same pattern, we'll find the missing term. We continue the pattern. The missing term after 9 should be 4 square, which will be simple, like 16, right? So following the next term is 5 squares of what? 25. So that is matching the sequence. So therefore the missing number in the series is 16, making the answer C, 16. So this question tests understanding of a square number, which are the product of an integer multiplied by itself. Let's take an example of cube series. So in the question it says find the missing number in the cube series 1, 8, 27, and then we have to find that missing part, then 125. We see we have all the options here, and we know it's kind of easy that you'll find it, but we have to know the patterns, right? So this series features cube numbers where each term is the cube of consecutive natural number. So the first term says 1, which is just what? Cube of 1. Then the second term is 8, which is cube of 2. Then the third term is 27, which is just what? The cube of 3. And then to find the missing term, we follow the same pattern, and the missing term after 27 should be what? Cube of 4, which is 64. So the term following the missing one, after that it is cube of 5, which is 25. So fitting the sequence given. So therefore the missing number in the series is 64, making the correct answer C, 64. So this question helps in understanding cube numbers, which are the result of number multiplied by itself. Now let's take an example of Fibonacci series. So in the question we have like 0, 1, 1, 2, 3, and then the missing part 8, and then 13. We have the options, and one of these is the answer. So the Fibonacci series is a sequence where each number is the sum of the two preceding ones starting from 0 and 1. So when we start with 0 and 1, the next number is what? 0 plus 1 equals to 1. Then 1 from the first step, what we do? Plus 1, which is 2. So the next number is 1 plus 2 equals to 3. So continuing this pattern, the missing number is found by adding the two numbers before it, which will be like 3 plus 2 equals to 5. So the sequence up to the missing number is 0, 1, 1, 2, 3, 5. And following this pattern, the next number are indeed 8 and 13 as given. So therefore, the missing number in the series is 5, making the correct answer 5. Okay, let's take an example of alternate number series or mixed series. So in the given series, we have like 4, 9, 6, 11, and 8. And we have to follow the pattern and find the right answer. So the solution is the pattern actually alternates between adding 5 and subtracting 3. So when we have 4, if we add 5, what we get? 9. And when we from 9, if we subtract 3, we get what? 6. And in the same pattern, if we do with 6, we add 5, and what we get? 11. And now our next job is what? From 11 we subtract 3 and we get answer 8. So to find the next after 8, what will be the pattern? Same, right? We already subtract 3. Now it's time to what? Add 5. So we should be getting what? 5. 8 plus 5 equals to 13. So therefore the correct next number in the series is 13, which means the correct answer should be C, which is 13. So this shows the importance of carefully, following the established pattern to find the correct answer. So in that way you can answer these kind of patterns and mixed number, also sometimes this alternate number series, and actually the question comes from this section. Now let's take this similar example. You see, we have the series which follows the pattern something like that: 12, 7, 21, 16, and 13. We have to find the right answer from the options given below. So the series actually what? Follows the pattern of alternately subtracting what? First 5 and then what? Adding 14. So let's say 12, and if we subtract 5, we'll get the next one 7. And what? When we add 14 to 7, we'll get what? 21. And now the next pattern is what? We have to subtract again 5, then we get the answer 16. And now it's the pattern of adding 14. So if we add 16 plus 14, we get what? 30. So the next number will be what? It's time to subtract 5 and we get the answer 25. So it's a similar, and that's what kind of question we usually get. So guys, that's all for number series. For more practice, you have to do on your own, or you just go to our section of quizzes where you'll get all kinds of question based on number series. And we have separate mock test on number series that you can attend in our app. So thank you so much, and I'll see you in our next session where we'll talk about letter series. Thank you so much and have a good day. Bye bye.